Okay, so this is our lesson on proofs and writing a T-proof. We're actually going to finish up the chapter with this section. Some of the examples from section 6 are pretty similar. I'm not going to have you guys do paragraph proofs in this class, so primarily what we're going to do when we get to proofs in other chapters will look like this. So we're going to kind of focus in on what they look like this section and maybe jot down a few things that pop up all the time so that we have them on a short list for notes. So learning goals are to complete 2-column proofs, and some properties of congruence will pop up. They should actually already be in our notes, so we should be good with that. So first of all, and again, you don't need to write this down, it's a logical argument that uses deductive reasoning. We talked about this chapter to show that a statement is true. And there's several formats or several ways you can do a proof. The way we're most commonly going to do it in this class is by doing a 2-column proof. So similar to what we saw, and we actually worked this one out at the end of section 4, are going to be some problems where we have to, first of all, take something that's given, like you can see here in this lesson, and then prove something at the end. So it says here that we are given that the measure of angle 1 is congruent to the measure of angle 3. Now, when you do a 2-column proof, just like when we did algebraic proofs, you're always going to start with your given statement on the left. So the given statement right there, you can see is the measure of angle 1 is equal to the measure of angle 3. And the first reason is always going to be given. Now, from that, we see that we have the angle addition postulate. And I can see here that they want us to incorporate the measure of angle DBA. Well, if I look, DBA is this angle right here. So DBA, it looks like, is the measure of angle 1. Excuse me, the measure of angle 3, not 1. The measure of angle 3 plus the measure of angle 2. Now, you could write 2 plus 3. It really doesn't matter. But I'm going to try and keep it the same as this line right here below. Now, the second statement has a blank to fill in, but we are using the substitution property of equality. Again, substitution is just where we take two things that are equal and we can replace one with the other. So if I look up above at the very first statement, I have 1 is congruent to 3 or 1 is equal to 3. So in this line right here, what I'm going to do is I'm going to replace the measure of angle 3 with the measure of angle 1. I use substitution. Now, reason number 4 says angle addition postulate. And then it says that we took the measure of angle 1 plus the measure of angle 2. Well, if I look at the angle that's formed by those two, that's the measure of angle EBC. Now, if I look, I have the measure of angle, or the measure of angle DBA is equal to the measure of angle 1 plus the measure of angle 2. I also have the measure of angle 1 plus the measure of angle 2 is equal to EBC. So using the transitive property, I can throw out this middleman, measure of angle 1 plus measure of angle 2, and just get my statement that I wanted to prove, that the measure of angle DBA is equal to the measure of angle EBC. So again, there's really not one way to do a lot of proofs, but when we have fill in the blanks, you guys, we just kind of use context clues to help us along the way. So let's try. This one's kind of a nice one to segue into our geometric proofs because it has a little bit of both. We have some algebraic stuff and some geometric stuff. So go ahead and pause and try this one. Now that you've had an opportunity, the first one is kind of hopefully a give me. This is always given. Now, for some of these other ones, they're going to be ones that pop up all the time. So for instance, if you see definition of a midpoint or if you see midpoint, bisector, things like that, if you see a key vocabulary term in one of your statements, odds are the very next statement and reason are going to use it, and your reasoning is going to be definition of whatever that thing is. So if you see something like an array bisects an angle, your next statement will have the two angles congruent, and your next reason will be definition of an angle bisector. Okay, that happens very regularly in this class. So we'll want to watch for those key terms because they pop up all the time. And then we can just say definition of whatever in our proof. The next thing down, and again, we wrote this down in our notes, and it was a bonus question on the test. You can see that ST is congruent to TU for the segments. The next line down is just a change in notation. Okay, all we did was change the notation so that we can do some math. Whenever we have that change in notation, we just write definition of congruence. Okay, that's all they did was they did a change in notation. Now the next line down, and they kind of did it all at once, which is fine, but they see up here that ST is equal to 7x, and they plugged it in. TU is equal to 3x plus 20, and they plugged it in. So I would say that this is the substitution property of equality. And then from here, we just want to solve. So the next line down, my next step in solving this would say 4x equals 20. You can see that that was the subtraction property of equality. And then lastly, we divide and solve and get x is equal to 5. So again, kind of a good segue because they use some key terms from geometry. They use some key stuff that we're going to see all the time. And then we worked our way back into doing one where we use some algebra properties of equality. Again, the reasons used in a proof can include definitions, properties, postulates, and theorems. A theorem is a statement that can be proven. Once we prove a theorem, you can use it to prove other proofs. So keep that in mind. Here are a list of theorems. Now, we're going to do a proof that's going to look really silly that proves one of these properties. Just understand all of these properties are already in your notes. It's saying that they work with congruence as well as equality. So these are all in your notes as properties of equality. Just add that they are also properties of congruence to your notes. If you want to pause and write them down, that's fine. But understand, they're saying the same thing we wrote down last week. So in some of your problems on your homework, it's nice and easy because you're just asked to say what the property is being illustrated. So if I look at statement A, it says T is equal to V, V is equal to R, T is equal to R. They threw out the middleman. So that's the transitive property. Okay, and this one would be the transitive property of congruence instead of equality. I don't care which one. You can just put transitive. Okay, B, JL is equal to YZ. YZ is equal to JL. They just flip-flopped. That would be the symmetric property of congruence. Okay, again, you can just put symmetric. Okay, so proving the symmetric property. Again, it's going to look kind of silly and repetitive, but that's how these are. They're super easy. I'm not going to put one like this on the test. It's just doing this so that we can use it later on down the road. So again, first statement is always going to be our given statement, and our reason is given. Notice here it says definition of congruent segments, so we're just going to change our notation. Okay, they're using the symmetric property of equality that we learned last week. So that means we're just going to take this and we're going to flip it. And then wouldn't you know it, if you look at the next line down, they changed the notation again. So we are just going to put definition of congruence. Again, kind of a silly proof, but it's just showing you on one side we're using the properties that we already know. On the other side, we're getting to the stage where we prove that it's true. Okay, so the last one here, and again, this one's going to be kind of a mixture of algebraic and geometric. But if you want to pause and copy down the blanks and fill them along with me, or even if you want to pause and try to fill this in on your own, and then as you go through it, we can look at some of the answers. Okay, so first statement, again, let me erase all this chicken scratch. The first statement, again, is always going to be the given. Let's undo that so that doesn't pop up all the way. Okay, so there's our given statement. M is the midpoint of AB. Obviously, the reason should be given. Okay, now I'm using the definition of a midpoint. So whenever we have a midpoint, we need to understand what that gave us. That just gave us two congruent segments. So we should have, hold on, Charlie. We should have AM is congruent to MB. Notice from the second line to the third line, all they did was change the notation. Charlie, hold on. So that's definition of congruence. Again, you can just put the notation like I have up above. Now, the segment addition postulate is kind of funny. Again, segment addition postulate, we should remember, is part plus part equals whole. Typically, if you see midpoint, we really don't use it, but for this proof, we will. So for segment addition postulate, we want to take part plus part equals the whole thing. And I'm guessing that's what they did right here. So AM plus MB is equal to AB. Now up above, we just said AM is equal to MB. Now there could have been two ways about going to do this. Just the way that the proof went, we want to keep AB as part of our problem. Okay, AM, not MB. So instead of writing MB in this next line, they're going to substitute another AM. So now we're going to say AM plus AM is equal to AB. And we can combine our like terms. Now the notation here is kind of weird. The book puts the distributive property. I did that all at once. The book puts the distributive property, which I'm not a huge fan of. I would rather put simplify on that. We really didn't multiply through parentheses. So I'm going to cross that out. And I'm going to put simplify. Okay, and then lastly, if I want to isolate my AM, I would divide the 2 to the other side. Okay, so take your time, write those down. I know I went through those kind of quick, but a lot of these you'll notice are just properties of equality. We were just using these properties of equality with segments, okay? So none of that was really that new. It was just we had to reason our way through it to get our answer, okay? Last thing, don't worry about number 4, but just write down what the properties are being illustrated. I'll let you pause real quick and try it. Okay, so number 2 is the reflexive property. And number 3 is the symmetric. Okay, so in summary, we should be able to take a 2-column proof and reason our way through it. Again, on the left side, we have our statements. Again, the guiding part should be what do we need to incorporate to get to our thing that we want to prove. And then along the right, all you're doing is putting the reason you're allowed to make the move you made. Okay. Again, nothing will be super proof heavy, but we will do proofs off and on throughout the course of the year. I'm also going to be posting a good chapter review for us that we can go over together as well. But as far as this lesson goes, you guys, take your time, ask lots of questions. Tomorrow's going to be kind of a work day mixed with a review day, so make sure we utilize that in class.